I'll start sharing the presentation here. Slides. Let me know if you can see it.
Yes, we can see.
Fantastic. Okay, well, first of all, thank you for organizing the training. It's always great to get closer to clients, as the product is quite simple, but we always like to take the chance to focus on the important parts to make sure that all the experience with the battery box is as seamless as possible. So that's why today we're going to go from the point of view of an understanding the sales side of things. So why is energy storage here to stay? Where is there a market for the future? And then we'll go into the battery box first, understanding the company behind it, BYD, and then going deeper into the product and finally on the installation side, finishing with some examples of cases to inspire possible installations. So first of all, energy storage. What is the reason why we're hearing so much about energy storage these days, and we believe that it's not only a market of the future, but also a market of the present? So there's right now two big drivers that have pushed energy storage into the limelight. The first big factor is the rise of renewables, and I was actually reading this morning that the renewable energy capacity installed in 2020 was the highest since 1999. Well, the growth was the highest since 1999, as it grew about 50% from the previous year. So this is becoming a very major part of all the electricity grids around the world. But as we understand, the sun doesn't shine when we want, and the wind doesn't blow when we want either. And the second big driver is on the demand side, on the electrification of things, and the big electrification force is of course the electric vehicles. In this first slide, I just show you the size of, well, the amount of kilowatt hours of electricity that you would need for a regular electric vehicle. And for those of you that are in the sector, you probably are thinking, well, this amount of kilowatt hours are fairly reasonable to produce in the spring, summer, in even a domestic setting. However, as you can understand, once again, the problem we mentioned before, uh, that generation is not always happening at the time that you want to consume it. So if you can see in this graph, the red line is the weekday consumption of a family that has an electric vehicle, and as you can see how it spikes up at the end of the day. So after 5 o'clock. So regardless of the time of the year, well, maybe in the heat of summer, it might still be possible to get a good generation at that time. But most of the rest of the year, this means that a generation will come during the day where there's no electric vehicle, and then at the end of the day, when they plug it after work, then they will need to get a battery to move the one time to the other. But they're probably thinking, well, the battery of my car is actually quite large, 40 kilowatt hours, 50 kilowatt hours, etc. So like, well, that can make my investment quite high. However, once you start looking into the actual this is statistical, of course. I'm sure there are some people that make trips of 200 kilometers every day, but for most, we take the bulk of the population, that then about 50% of their trips were going to be below 30 kilometers per day. This means that they would just need about, there's one of the smallest batteries, about 5.1 kilowatt hours to cover those trips. If this is a person that wants to make sure that most of the days the battery is up to 100%, and the ones just a tiny bit left to charge in the weekend. So there are about 80% of the trips will be are considered to be below 60 kilometers. So a battery of 10.2 kilowatt hours would be enough to power that. And finally, if they really want to cover all possible trips with a slightly bigger battery, 15, 16 kilowatt hours, they will be able to cover that. So these are the two big drivers: renewable race of renewable energy and electric vehicles, that we think are bringing energy storage for the grid and the government's point of view, and also from consumers' point of view, is as adding more demand for energy storage. So then how do we have this conversation with a client. What do clients normally care about? And then this is a survey of German consumers that they have been adding energy storage from 2013 to 2017. Of course, I'm sure the drivers have changed a little bit in the recent years, but the first part that surprises us is that when they make the decision, the return on investment tends to not even appear among the top reasons why they add in the product to their house. As you can understand, it's a major investment in a house, but especially for consumers, not everything has a return on investment, such a fridge, a washing machine, etc. In your house might not have a return on investment. So the drivers that push them to select one or the other are slightly different than what we think. The first is the sense of control over the energy bills. It's true that it is related to the return on investment, but it is slightly a more emotional factor, because it is the one about having control, having being able to generate their own power, consume their own power, as a very satisfactory feeling. And it is also quite related to the fact that we have seen in factor number 3, which is the one that is growing the fastest in the last few years, is getting this sense that, well, everything around us, we are hearing that there's this problem with climate change, we have this problem with pollution. What can I do? And then adding a renewable energy plus energy storage system to their house provides them that sense that at least the energy that I'm consuming, I know for sure is clean energy, so I'm doing my part in this challenge. And another one that we have seen quite a bit is the protection against power failures. It depends on where they are based, but it tends to be a big driver in some regions where power is unstable. So there's 3 types of installations, I would say. So you have the pure on-grid systems, you have the backup systems, and you have the off-grid system. So when you're designing an on-grid system, the big focus should be on utilization of the equipment, meaning this is as we mentioned before, it's a big investment. It's a costly equipment. So we want to make sure that the customer gets the most out of that, so it gets used as much as possible. These, in practical terms, when it's an on-grid system, tends to be a utilization about 60 to 70%, or the grid independency, of 60 to 70%, because as you can see in this graph that compares the kilowatts peak of the PV that you have installed compare with the megawatt hours of consumption of the of the house, and also on the vertical axis the capacity of the battery in kilowatt hours compared with the megawatt hours of consumption per year. You'll see that you will have to oversize quite enormously both the PV and the energy storage to reach 100% utilization. So it's a lot easier, it's a lot more common to find systems that are between 60 and 70%, and that should be something quite satisfactory for customers. And then later on, if they have collected the data, they know how much they're consuming, they know how much they're exporting and importing, they can decide 1 year, 2 years later to add more batteries to make the system to increase the grid independency. Then in backup systems, this is less of energy calculation, and it is more of a power calculation. So as you see in this graph, you can see the different consumption of different types of appliances. So you can see in this home that most of the time they're just consuming about 500 watts. So it's a really low base load. But as soon as they connect particular appliances such as the dishwasher or the electric stove, these power consumption multiplies enormously up to almost 5 kilowatts of power. What this means is that if in a backup system you connect all the appliances to the energy storage system, then this energy storage system must be able to power especially in the beginning of a dishwasher or washing machine, these are motors to have a big surge in the beginning of each load. So in general, you need to help the customer understand. Do you want to power your whole house with a battery? Then you probably need to much bigger battery than what you were intending to do self-consumption. Or maybe you want to split up and have the emergency circuit, or be conscious of the appliance that you want to switch on when the battery is powering the house, and then a regular circuit that only works when you're being powered by the grid. And finally, the off-grid systems. So we have a document that I'll show you later called the minimum configuration list, in which that we recommend a number of batteries per types of inverters. These are especially designed for off-grid systems, because these amount of batteries would be able to withstand the surge power, the maximum surge power that inverter can allow. Because it is hard, many times it is hard to calculate in advance, especially even when you're building off-grid systems, and for people that are used to designing off-grid systems, because the type of load that you're connecting would have a great influence, especially on the the transient power, so the surge power. For 1 or 2 seconds, you might have really big power surges. When you, for example, when you switch on a pump, many people don't realize that a pump for 1 or 2 seconds will multiply the power by 7. So you need to size the energy storage system to support 7 times the power of your load. So you normally, off-grid systems tend to be significantly oversized to be able to withstand those power surges. Okay, and now let's go into the battery box itself. So the first part that is always important to mention is the company behind it. So BYD is becoming a more well-known company these days, as you see more electric vehicles coming around Europe. It has been known due to the public transport vehicles, but in the recent times we hear more and more. But this is actually a company that has been, it was created in 1995 in the city of Shenzhen in China, but actually has become one of the major players in the sustainability sectors, or renewable energy sectors, and that's why it has been. Last year was considered by Fortune magazine as the third company changing the world. And Wang Chuanfu, the founder of BYD, was among the Green 30, so the sustainability champions of 2020. And it's not only from a company point of view, also from a technological point of view, as the BYD Blade, which is the new battery that is being used only for electric vehicle applications, is considered to be changing the paradigm of electromobility. One of the reasons why BYD is considered as such a pioneer or such a champion in the sector is because it always has had sustainability at its heart. So from really early on, Wang Chuanfu and the founder of BYD understood that a small amount of vehicles were generating large amount of carbon emissions for the world. So a focus from the early stages on becoming the number one electric bus commercial vehicle manufacturer. And this is because BYD was created with the idea of creating a world of zero emissions, a zero emissions ecosystem. In order to do that, it had to be able to provide all the necessary equipment for it. So going from solar panels, energy storage, energy storage systems to store that electricity, and finally they focus on one of the largest consumers of energy, which was cars, making electric vehicles. And of course, when you're trying to create a world of zero emissions, there's no better way to reduce emissions than not producing what is unnecessary. So that's why we want to make sure there's a zero focus towards zero waste, and that's why every 100% of the batteries that are delivered by BYD are being taken back when they reach the end of their life. And this is the case of in the case of Europe. This is something that EFT Systems ourselves in Europe are taking care of, the collection of all the batteries, sorting them, checking them, refurbishing, and finding a second use for them. And when it's not possible to provide a second use, finally sending them to recycling. And BYD understood that in order to deliver this vision, this sustainability vision, they couldn't rely simply on regular supply chains, because we understand there's going to be shortage of materials, there's going to be shortage of engineering, there's going to be a shortage of recycling facilities, because this is a very fast-growing market. So BYD decided to be fully vertically integrated. So from the mineral resources, meaning that BYD is a owner of the sources of the lithium, all the and all the different carbon, etc., all the materials necessary to build their batteries. And on the opposite end, every cell manufacturing plant of BYD actually has recycling facilities. And now we go into the battery box, and how does the battery box benefit from being produced and developed by BYD? So first of all is its track record. So BYD as of today has probably one of the largest, if not the largest, probably has the largest electric vehicle fleet in the world. And the same batteries that have been used in those vehicles and are the battery cells that we have used for the battery box, meaning that we already know quite a lot about how they degrade, how long they live. So we have taxis like this one. This is a Model E6 that they have run for over 1 million kilometers. So we know the reality of the life of these batteries. And on the other hand, is thanks to the economies of scale, the size of BYD being the world largest manufacturer of lithium iron phosphate batteries, can benefit from fully automated cell manufacturing and almost fully automated production, even the battery box. And by BYD being an automotive manufacturer, even the battery box production line is ISO TS certified, meaning that it has the total quality certification for the automotive sector. The second pillar, when we speak about the battery box, the second part of the DNA is the lithium iron phosphate chemistry. This battery was originally developed with the idea of being created with very commonly available and non-toxic materials, but also with a very big focus on safety and reliability, because it's a very thermally stable battery, meaning that it can, even in the case of a short circuit, like you can see in the top left test over there, there is not a possibility of a fire and explosion. I've put here in the presentation a link to a video that you can see later on when we share the presentation, but essentially showing a short circuit test that shows how regular nickel cobalt manganese battery, which has been the most common battery until now due to its high energy density, compares with a lithium iron phosphate and the BYD blade batteries. So it shows how it's not possible to have any fire or explosion, even in the case of a catastrophic failure. And the next part is the flexibility. The flexibility is very much what identifies the battery box product, and this manifests itself in many different ways. The first one, of course, is the flexibility of capacity. With the battery box, the same family of products, it is possible to start from a very small capacity of 4 kilowatt hours when we are an LVS model, and up to 983 kilowatt hours by putting 64 of the LVLs in parallel, and that's in a single system. This wide range of capacities allows you to apply the batteries for many different applications. So it could be single phase, three phase, commercial, residential, on-grid, off-grid, etc. So all sorts of applications you can think of for energy storage, you can find a battery box for it. And this flexibility is also applies in time, which is quite interesting. As I mentioned before, when we were talking about designing on-grid systems, this allows customers to start small. And we always encourage you to start small, make sure that people are using 100% of their batteries and as much utilization as possible. And then once they have collected enough information, maybe 1 year of running, where they see really how much energy they consume at different times of the year, they can decide to add more one, two, three more batteries. And in the even if those batteries are connected in series, like it's the case of the high voltage system, you won't see any significant degradation in the first year, so there shouldn't be an issue. And if you add them in parallel, which is the most common case in low voltage systems, even in a few years down the line, this will not affect the capacity of the new batteries. Another element of flexibility is, of course, the flexibility of function. So the inverters are really the brains of the installation. These are the ones that that add the functionality to the system. So we always want to focus on, well, we ourselves want to focus on providing the best possible batteries, and we want to partner with the market leaders on each of the segments on the inverter side. And the batteries work for they are applied for many different environments, going from very cold, well, -10 degrees up to 50 degrees of the temperature range. And most of them, they are IP55. All of them by the LVL are IP55, meaning that they can be installed outside, but it needs to be covered, reasonably covered, to make sure that they are not falling under the snow or constantly under sunlight. And finally, performance. So this graph that I show you here was the result of the SPI testing, so the System Performance Index testing that HCW does every year. And this is a test that was developed with the idea of creating a universal value of efficiency. So a way to compare battery and inverter together, all possible combinations available in the market of battery inverter or even the all-in-ones, and compare with each other and see the result. And we're quite proud that we have been #1 for the 3 years that this test has been running. So the first year with SMA, second year with Costel, and last year with Fronius. So summarizing, the battery box, you benefit from the support of having BYD behind it, the use of the lithium iron phosphate chemistry, the flexibility that it provides in all different dimensions of flexibility, and all this with the highest performance in the market. So now let's go deeper into the individual products. So the first one we'll speak about is our biggest seller, the high voltage systems. So we have 2 models in high voltage, the high voltage small and the high voltage medium. The high voltage small these are 25 amp hour, 100 volt modules that by putting 2 of them together, as they are connected in series, they will reach 200 volts for the small one. So that's 5.1 kilowatt hours of capacity. And you can have up to 5 of them in a single tower, reaching 12.8 kilowatt hours of capacity. And it's possible to have three of them in parallel. When you put systems in parallel for high voltage, they must have the same amount of modules per tower, because the number of modules sets the voltage of the system. In terms of the high voltage medium, these are 50 volt, 50 amp hour modules, and you can put 3. You can start with 3 of them in series, meaning that will be 150 volts, 150 volt tower, and 8.3 kilowatt hours of capacity. And you can have up to 8 of them in series, having 22.1 kilowatt hours of capacity and about 400 volts of system voltage. And same as with the HVS, you can have up to 3 of them in parallel. As you can probably think, they look quite similar. So when should I recommend an HVS? When should I recommend an HVM? So the HVS has been designed with the idea of offering an easy entry option, meaning with a very small investment, you can have a very small system. So you can start with 5.1 kilowatt hours, and as it is a fairly powerful unit. Even in the case of a backup, then you need to use it for a power cut. Then you'll be able to power the appliances for a few minutes, for up to an hour, because when you combine, as the voltage is quite high, you combine that with a standard inverter. In this case, let's say 25 amps of current for the inverter. A 5.1 kilowatt hour system actually will provide you 5.1 kilowatts of power. So it's very high for the amount of energy that we are providing. But if you need anything larger, or customers have larger electrical appliances, or they want to be able to provide backup for several hours, we would recommend the HVM, especially because it not only start with a larger capacity, but also it provides you the option to future-proof the system, meaning that if the customer starts with 11 kilowatt hours, and then later on they add an electric vehicle in the same tower, they could add a few modules to reach 22 kilowatt hours, for example. It is always very important, as there are so many different combinations. It is very important to check in both, either the Battery-BOX website or the EFT Systems website, the compatibility list, because this will help you understand which combinations of batteries and inverter models are suitable and will be able to work. And once you have already decided which unit you're going to install, and it's already been designed for the application, then you go to site. The first step is assembling the battery unit, and this is one of the big identification factors of the Battery-BOX, is the fact that it has no cables in between. So the assembly of the modules is actually really easy, and you just need one screw to connect one level to the next. When you do this, just in general, we have never seen this issue in the field up to now. But just in case that you have doubts and you have several modules in your warehouse, some HVS, some HVM, you can differentiate them because they have is one bar for the HVS and two bars for the HVM, and they cannot be combined together. Remember, the HVS can have 2 to 5 modules in one tower. The HVM can be 3 to 8 modules in one tower. The second step of the installation is the connection to the outside. So as you can see, the whole battery has been connected without any additional cables, any connectors, etc. So now you open the front cover, and all the connections are in the same place. So going from the grounding in the bottom left hand side, then you have the communication connections to the inverter and to other batteries and to the internet, all in the same section. And then on the right hand side, you have the power connections. So always start with ground connection, because this one is not only from a safety point of view, but also it can affect the communication with the inverter, so the quality of the signal with the inverter. So make sure that it's always properly grounded to the grounding of the house. The second step will be the communication connections. So first one is the one to the inverter. So in general, each inverter has two options. So can either be an RJ45 connection, which will go into one of these bottom two ports, like one of these two ports. The left one is for CAN communication, and the right one is for RS485 Modbus. And the top, you'll have the possibility of putting one by one the pin to make sure that you don't need to rely on the crimping. So one would be more convenient, the other one you have a bit more control of the exact pins where they are connected. Then the internet connection. So internet connection, this is exclusively for the battery. So the battery will not communicate with their service service server through the inverter. It needs its own communication cable going from the router to the battery. And this will allow you to do remote updates if necessary, or a remote service if you have any issues. And finally, the power connection. This, once again, you're using a simple clip-in system, so you don't need any lugs or any connectors. You just put the cable in and close the pin. And finally, you close the cover. We make a slide about the cover because it is important to highlight that if the cover is open, the system will not switch on. This is a safety measure that we have introduced. So the cover needs to be safely locked to be able to switch on the system switch of the of the battery. And when you have the only difference between a single tower and parallel towers would be that you have to have a communication cable going from the master to the slave, and this is from the slave 1 to the slave 2. And if you have 3 towers, the middle tower would have a dip switch going to the right. And the final step would be commissioning. So commissioning is required for the system to work, meaning that you need to use an app or a computer program, which I'll show you later. So very important, the inverter must be off. Always the inverter must be off. So first thing, you switch on the battery, then use the BConnect app to connect to the battery and do the commissioning. And then once the commission has been successful and you see a white light in the LED, then you can switch on the inverter and do the commission of the inverter. So in order to do the commission of the battery, you can use both the mobile phone app, which is available in Android and iOS, or you can use the PC tool, which is the BConnect Plus, that this can be downloaded from both the BYD Battery-Box and from the EFT Systems website. When you're using the app to do the commissioning, the first thing it will require you to do is update the firmware. In order to make sure that you have the latest firmware, update the app before going to site, and download the latest firmware before going to site. And once you're on site, just connect to the battery Wi-Fi and update the firmware. The commissioning part itself is very simple. You just need to confirm the time, select the type of battery that it is, select the inverter that it is, and finally select if it's a single phase, 3-phase, or on-grid, off-grid. And once that is finished, you will see the LED light in the front of the battery go into white. This means that the commission has been finished and the battery is ready to connect to the inverter. After a while, if you leave it like this for after a while, you will see that the light turns into white and blue, and there will be a number of sequences. If you have a different a type of error, or if you have you're waiting for the inverter to communicate, you have different sequences for different meanings. So this is included both in the manual and the service guidelines. And actually in the service guidelines, it tells you what to do for each type of error. A very important thing to mention. So I've highlighted a few times that it is possible to add batteries later on. And it is very important because these systems are connected in series, meaning that the same current will be going through all the batteries. So all the batteries must be at the same state of charge. If you're adding one new battery and the system is at a different state of charge than the new battery, you are going to lose capacity. You will see state of charge jumps. You will see that you are getting a lot less energy that we were getting even before the battery was added. In order to avoid that, make sure that you only add new batteries when you are close to 30%. 25, 30, that range will be okay. So you can discharge the battery, and when it hits 30%, stop it there, or the opposite. When it's charging, stop at 30%, and then you can add the module in. Now we go into the low voltage units. First of all, the LVL. The LVL is our largest unit, the most commercial unit. each of the modules is 15.4 kilowatt hours, but I actually can put one on top of each other. So in a very small space, you can have 30 kilowatt hours of capacity, and you can have 64 of them in parallel, meaning that you can reach up to 983 kilowatt hours in a single system. The we've spoken before about the compatibility list and the minimum configuration. This is a bit of the version for off-grid low voltage units, as they can be used for off-grid, because these would allow you to confirm for this size of inverter, if I put these many batteries, I will not have any issues with the power surges that the inverter can let through. The system is composed of two items. Is the LVL unit itself and the BMU. The BMU is, you need one per system, only one per system, even if you have 64 of them in parallel, only one, because this is the communication interface with the inverter. And inside the LVL, all this is included in, is already assembled and included in the box. You have the BICs that come with each of the modules. These are collecting the battery voltage and battery temperature data, and the battery management system, which is the tray on the top of the unit, which has all the control logic, and it has the protections of the batteries. The installation, the first step of the installation is quite simple. You just need to put make sure that you put correctly one module on top of each other, and the connections will be internally. You go through, you open the covers, connect to the power connections and the communication connection on the right hand side. Just make sure that from the in of the BMS, it goes to the BMS port in the BMU, and from the inverter port you have the CAN cable. So we're putting Cat5 over there. That is essentially the base, well, the quality of the cable, but not all the inverters have a straight through cable, meaning that some inverters require you to change the pins, but this is all provided in the battery quick installation guide, and it is provided also in the manuals from the inverters. And the BMU will also be the one that will have a Ethernet port to connect to the internet. When you put two batteries one on top of each other, in order to make the installation neater and to allow you to have all the cables more organized, you can have the power and communication cables going through the inside of the top battery towards the bottom battery, but still always remember to have the same length and section of cable for each of the batteries going to the bus bar. When you have more units, you just need to make sure that you have a communication cable, a Cat5 cable going in between all the batteries, between the in when the out of the previous battery to the in of the current battery. And whenever you do the commissioning of the system, it will address them automatically. And you need to be just to be mindful of the switch on, switch off procedure. Same as with high voltage unit, make sure the inverter is off first, then click on one of the batteries. This will switch on all the batteries, and it will switch on the BMU. Do the commissioning, and when you finish the commissioning, you can switch on the inverter. And the switch off procedure will be the other way around. First switch off the inverter, and then press the BMU for 5 seconds, and this will switch off all the units. And finally, we speak about the LVS. The LVS is the smallest of the units, starting from 4 kilowatt hours per module. You can have a system with 4 kilowatt hours, but you can have up to 64 of those in parallel, being 256 kilowatt hours. But those 64 modules, they need to go in towers, and the towers, the maximum tower size you'll be able to do be 4 per tower when you have multiple towers. So you can have up to 16 towers with 4 modules each. And each of these towers will include the actual LVS modules, and a PDU and base will be on top and bottom of the unit. And then same as with the LVL, you'll have the BMU, which will be the communication interface with the inverter. So just one per system. In terms of the restrictions of these towers, so I mentioned before, you can have 4 modules per tower, but there is one exception. If you only have one tower, that one tower will be able to be up to 6 modules. But if you have more than 6 modules, they will need to be in several towers. It is as these are connected in parallel, you don't need to have the same amount of modules per tower. So you can have 4 in one and 3 in other. And then we get into the same as with the high voltage system. You have a dedicated installation area, and on the left hand side the ground connection, just make sure that it's going directly to the house grounding connection. Then the power cables, which we have developed some special connectors to make sure that the installation when you get to site is really easy. And on the right hand side, the communication ports. On the from the BMU, it will go to the input of the PDU. And if you don't have any more units, you'll have a RJ45, so the CAN terminator in the output. But if you have more units, it will continue the daisy chain. And then in the last one, you'll put the CAN terminator. So the first step is always a grounding and the communication. And then the power connectors that I mentioned before. So there are 2 options here. You can, well, there are 3 options of connectors: 35 millimeters square, 50 millimeters square, and 70 millimeters square. And you need to order the ones you need. So you need to speak from the wholesaler which ones are the ones you want. It is also possible to get the cables pre-made. So if you have an interest about this and you don't have them in stock, just let me know, and I can let you know where to find them. Then when you put them in parallel, same as with high volt system, on the LVL, make sure that all the cables are identical. And the only thing you need to take into consideration is that there has to be a communication cable going between the master and the different slaves. And in the last one, put the CAN terminator. The switch on procedure is the same as the LVL, meaning inverter must be off. You just need to switch on one battery. That one battery will switch on all the batteries in the system, including the BMU. And then once you have finished commissioning, you can switch on the inverter. And to switch off the inverter first, and then press for 5 seconds the BMU, and this will switch off all the batteries. In the case of the low voltage unit, it is not strictly necessary to put batteries at the same state of charge, but it is recommendable because it will allow balancing to happen faster. But anyway, in this case, you don't need to take special care about the state of charge of the units. Just if you don't put them at the same state of charge, just be patient until it gives them the chance to balance. And then there's a very important section. I always I like to remind people, if there's one thing you want to remember of today, would be this section. If you want to focus on something, it would be this. And it is the support tools that you have available. First of all, always remember the EFT Systems website. So here you have all the documents, all the firmware, and even the online service center. So everything you need to be able to install and to solve any issues, it will be over here. And one of the things that we have developed for especially for you is the service guidelines. So this is a document that we have elaborated based on the experience of working with thousands of installers and thousands of installations. So we observe what are the most common questions, the most common issues, and we first put a set of recommendations of things to check when you finish a system to make sure that it's installed correctly. Secondly, based on the type of issues that you're seeing, what action you should take. And finally, if following those actions you still haven't solved the issue, then you have all our contact information at the end of the document. A second part that is very important, is very useful from a service point of view, is the BConnect Plus. This is a type of program that is available at the top of the download section in the EFT Systems website. and it can be used in the computer. It can be used for setting up the system. If you don't have a phone with you, or your phone is giving you any issues with the app, you can use this to set up the battery system. And on the left hand side, it actually has some additional sections so that can help you diagnose if there's any issue with the inverter or the battery, or confirm that everything is okay. So on the first section, you have the system information, which show you the state of charge, the maximum cell voltage, minimum cell voltage, firmware versions, etc. Secondly, would be the detailed information of each one of the cells. Then it will allow you to update the firmware of the different components. And finally, very important, you can download the history of alarms of maybe you've had any issues in the past, or you have in a service case. This is where we will ask you to download so we can diagnose. But if you want to avoid having to do this on site, that's what the internet connection is for. So it is not required, but it's recommendable, because if one of your customers has an issue and you either want to go prepare to site, or you want to see if it's possible to avoid having going to site, with this information, this connection would allow us to do the diagnostic remotely. And once you have an issue, if we would always recommend to go into an online service portal and over there register a ticket. As an added bonus, even if you don't have any issues, we recommend you to register all your systems, because that would provide you the B Partner points. The B Partner program is it's a program that has been running since at least over a year. If you have been registering your systems, you'll see that you've been collecting some points. But we recently announced the benefits that you will be getting from those points, and that the status. So you'll be getting preferential service support. You'll be getting a shop where you can use your points to buy components. You getting a lot some e-learning, and you'll be able to show that certificate of achievement in your website, etc. So you can go into the online service center, go into B Partner, and check out all the details of the program. And this is you just simply have to register any of your systems over there, and you'll be collecting points. And finally, I always like to finish in with a little bit of inspiration. And over here, so I just show a lot of the different possible applications of the energy storage system, and so you can think, oh yeah, maybe I have a customer like that, or I could suggest that to this other customer. So first of all, the most common systems are residential on-grid systems, from single phase to three phase. You see the LVS on the left hand side for a single phase system, and the HVS on the right hand side for a three phase system. There's also residential off grid, where you can see an LVL here. Is for it's for actually a little cottage in the Caribbean. And quite interesting in these commercial application. This is a farm in Belgium that they were growing really fast, so they were needing more and more power from the grid, and eventually the grid told them, this is the limit that we have, so now you need to pay to upgrade the substation and the transformer, which, as you can imagine, would be a very, very high cost, and they were not getting any return on investment from that. So then they decided to look into the possibility of generating and consuming their own power. So as of today, they are essentially off grid. They are only consuming from their own system. And thanks to that, and thanks to saving the investment from the grid, they have a payback of just 4 years, which is quite similar to what we are observing in large residential systems for communities that want to add electric vehicle charging, because especially when it's fast charging, it can be quite high power, and their local distribution network might tell them that it's not possible, or it requires them to pay for the upgrade. So in many of those cases, it makes more sense. It actually makes more financial sense to add their own solar system, their own batteries. So they are saving, and they're saving energy through self-consumption, but also they are saving significantly in the investment, because once they reach the maximum power, they can pull from the batteries rather than pulling from the grid. So they are acting effectively as a peak shaving system. Then other option is other application we have seen, especially in sub-Saharan Africa, will be microgrids and or large off-grid systems. So batteries overall have had always a place in the microgrids around the world, but what we have observed in the last few years is that more and more of them are finally trusting lithium ion. They realize that even though the upfront cost is a bit higher, their return on investment is significantly better than lead acid batteries, and it also requires a lot less maintenance and more reliable, etc. And overall, anything you can think of that will require electricity. So on the left-hand side, you can see an off-grid bar. On the top right, you see a device that is used for construction. So as you can imagine, if you're building inside a tunnel or an underground and so on, you want to avoid as much as possible having fumes. So in many places they are transitioning towards zero emissions construction devices. And in the bottom right hand side, this is actually a device for the military. So in their case, it was less about the pollution or energy consumption. It was more about silence. So they wouldn't be noticed in their operations. And that's it from the presentation point of view. I don't know if you have had any questions, but feel free to ask now, and we'll get a few minutes to answer.
Thank you very much, Alvaro, from nice presentation. Okay, questions. I have a couple of questions. Let's start. What is the best selling battery type, HVS or HVM?
Depends a lot on countries. Overall, I think HVS might have sold a bit better than HVM, because for most residential systems tended to be between 8 to 10 kilowatt hours are the most popular in residential systems. But especially for countries that they are three-phase or they have large uptake of electric vehicles, HVM is a slightly better solution, which allows them to go 12, 15, which is it's a more common capacity for large residential systems.
What is battery's lifetime? How many years? How many cycles?
So the only hard value we provide is the one of the warranty. So the warranty provides 10 years, and it's a certain energy throughput. It's equivalent to about a cycle a day. But the reality is that we know that the battery will not be the first item of the system to fail, because the batteries will continue losing a bit of remaining capacity for many years after the warranty is done. But you do have electronics that might need to be replacing. You might have the inverter that might need replacing. And also in 10, 15 years, we expect that a battery that is this big might be this big. So maybe customers at that time, they want to change to, as the capacity goes lower, they might want to replace the batteries by something smaller.
Okay. If we have existing battery system, and after 2 or 3 years we want to add batteries, is it affecting if we will add new battery to the existing older system?
Okay, so there's two ways of adding batteries in our case. In the case of the battery box, especially if it's high voltage, you have the possibility of adding more modules in the same tower, or you have the possibility of adding more towers. If it's more modules in one tower, those ones are connected in series. So as you connect in series, there's no way around it. If the batteries have already lost some capacity, the new battery will lose capacity. It will have as much capacity as the worst of the ones in one tower. But if you add another tower, you won't be affected by that. As when you add more towers, because they are in parallel and each of them has its own BMS, then that is managed. The system is capable of understanding that different towers have different state of health. So it will use 100% of both.
Mm-hmm. Okay. What is your forecast of a battery price? In one hand, the demand is increasing. On the other hand, raw materials price are more and more expensive. What's your forecast?
So first of all, it's important to note that the materials that have been going up are not affecting lithium iron phosphate batteries. So it was more cobalt and nickel, the ones that have been growing the last few months, and those ones don't affect lithium iron phosphate batteries. I know that even steel has gone up, and steel, of course, is used for the housing. So this is something that we can. It doesn't matter if it's a battery or if it's a computer, will be affected. But the way prices evolve, it's not that much that we reduce prices. It's more that every year there are improvements in energy density. So what you're getting is for the same or a little bit extra cost, you're getting a lot more capacity. So that is how you will see the evolution of prices. So in the last 5 years, I have been seeing 5 to 10% improvements per year due to that improvement of energy density.
Is it basically same like with solar panels?
Yeah. Batteries, I would say, they are so far less volatile than solar panels. We don't change prices every month.
But yeah, every year panels will also be more and more power.
Yeah.
We'll get yeah, please, more questions.
What would be the electricity price that the batteries are efficient in the market?
Do you mean what price of electricity?
Yeah, I mean network electricity, not solar electricity.
So I don't fully understand the question.
Usually, if we are using the batteries, then the stored energy in the battery should be a little bit less expensive than the electricity from the network.
Yeah.
I mean that. And if the electricity price in the network is 10 euro cents, is there the place for the battery?
Okay, so I cannot tell you the levelized cost of energy because I don't know at what price the end consumer is buying the complete system. And it's not only the battery, they have to pay for the inverter, for the cables, for the installation company, etc. So I would do some kind of I would divide that by the lifetime kilowatt hours that you estimate for that system, and that will give you the levelized cost of energy, and compare that with the electricity cost. But I mean, I know that in Germany that electricity cost is probably about 18p or 18 cents or so of euro. It's a pretty good investment. If in Spain that is about a third of that, about 6 cents, it's not so good. It would be somewhere in between there. So the closer you are to the German one, 15 to 20 cents would be would probably make sense, but you need to look at the exact levelized cost of energy for the particular customer.
Okay, thank you. Maybe, sorry, I didn't hear from the start. I had another meeting. what would be the price of 1 kilowatt-hour of battery storage approximately?
As I say, it's very hard for me to mention because we sell to distribution sales to installer sales to end customers. So I really don't know at what price of kilowatt hour is being brought into the person actually going to use the battery.
Okay, more questions, please. Okay, seems we don't have no questions. Okay, thank you very much, Alvaro, for presentation.
Thank you very much for organizing. I hope this is useful, and once you get out there and you see real cases, real installations, I'm sure you'll have more questions. So feel free to send them over later on.
Thank you. Please share your presentation and.
Will do.
Yeah. Thank you very much.
Have a good day.
Okay, bye.